Everyone, myself Malika sir and my department is BS Chemistry. Today I will take you on a deep dive into berkelium, a rare, synthetic and highly reactive element. We will explore its discovery, properties, production, uses and the significant risks it poses to health and the environment. What is berkelium? Synthetic element. Berkelium does not occur naturally in the earth crust, it is made artificially in laboratories. Actinide series. It belongs to Actinide series, which includes elements with atomic number from 89 to 103. These are known for their radioactivity. Discovery. Berkelium was first synthesized in the December 1949 by scientists at University of California by bombarding 241 with alpha particles helium nuclei. Naming. The element was named after the city, following the tradition of naming element after places or scientists. This means it has 97 protons in their nucleus. The most stable isotope Bk247 has a half-life of about 1380 years, which means it takes that long for half of a given amount of decay. Physical and chemical properties. Physical properties, its appearance. Berkelium is a silvery white metal when freshly prepared, similar to other actinides. It has a high density of 14.78 gram per centimeter cube, denser than iron and similar to protium or uranium. Its reactivity quickly with oxygen, forming a thin layer of berkelium oxide BKO2 on its surface, which protects the metal Actinide for further oxidation. All isotopes of berkelium are radioactive. Even tiny amounts can be extremely hazardous, emitting alpha particles that damage the living tissues. Its radioactivity makes it highly toxic. It is handled only in specialized facilities with strict safety protocols. Berkelium is almost never seen in bulk form due to its danger. For example, if you had a piece of berkelium in the open air, it would quickly thrash as it reacted with oxygen, and even standing near it would be dangerous due to radiations. How berkelium is produced? Not naturally occurring, berkelium is not found in nature, it must be synthesized. Synthesis process. The most common method is neutron bombardment of curium 244 in a nuclear reactor. Curium 244 is placed in a reactor where it is absorbed neutrons, transforming into curium 245, then curium 246, and eventually into berkelium 247 through a series of nuclear reactions. This process is done under strict control to manage the intense radioactivity and prevent the contamination. Only a few grams are produced each year worldwide, mainly for research. Imagine the effort and resources required to contain or create just a few grams of the element. Chemical reactions of berkelium with halogens. Berkelium react with halogens chlorine, bromine, and fluorine at high temperatures to form halides 2pk plus 3Cl2 to form 2pkCl3. BKCl3 is a light green solid with water hydrolysis. Berkelium reacts slowly with water or moist air, forming berkelium hydroxide and hydrogen gas. BKOX3 is the precipitate. Formation of berkelium fluoride. Reacting fluoride is just a few number. Reacting berkelium chloride with hydrogen fluoric acid form the or produce the berkelium fluoride, a very stable compound. These structures or reactions are only studied in lab designed to contain radioactivity, since even a small spill can have a serious consequences. Applications rare and research based. Research and development. Berkelium is used mainly to create even heavier elements. For example, it was used to help discover element 117. Nuclear chemistry. Scientists study its natural or nuclear properties, such as how it decays and what particle it emits. It helps in producing elements beyond uranium, which are often unstable and exist only for a fraction of a second. Due to its rarity, high cost, and extreme radioactivity, berkelium has no practical commercial applications. Some researchers has a heavy super heavy elements created with berkelium may one day be useful in advanced energy technologies, but this is purely theoretical. Can you think of any risk or ethical concern in creating new highly radioactive elements just for research? Berkelium and radioactive waste. Sources of radioactive waste. Berkelium, like other actinides, is a significant component of high-level radioactive waste from the nuclear reactor. Long-lived isotopes. For example, BK249 has a half-life of 330 days, meaning it remains radioactive for nearly a year before decaying, and BK247 lasts much longer. Decay products. As berkelium decay, it can form other radioactive elements, compounding the waste products. Specialized disposable. Handling and disposing of berkelium waste requires advanced technology and strict safety measures to prevent the environmental contamination. Dangers to ecosystems. Soil and water contamination. Even small amount of berkelium can contaminate soil and water, and making them unsafe for plant, animals, and even humans. Food chain entry. Radioactive particles can enter the food chain, starting with plants and small animals and moving up to larger animals and humans. Biomagnifications. Genetic mutations. Exposure to magnesium or beryllium radiations can cause mutation in living organisms, potentially leading to birth defects, cancer, or ecosystem disruptions. Long-term impacts. Because some isotopes have a long half-life, contamination can last for centuries or longer. How do you think radioactive contaminations in the environment could impact the future generation? Impact on human health. Internal exposure through inhalation or ingestion can cause the severe tissue damage, burns, or organ failure over time. Increased cancer risk. Long-term exposure increases the risk of cancer, especially in the lungs, bones, and liver. Alpha radiations. While alpha radiations can't penetrate the skin, they are extremely dangerous if inhaled or ingested, as they can directly damage the internal cells. Protection measures. Workers handling berkelium must use the suits, work in shielded environments, and follow the strict safety protocols. Why do you think alpha radiation is so much and more dangerous inside the body than outside? Handling Handling radioactive waste. Deep geological. High level radioactive waste, including berkelium, is stored deep underground in stable geological formations like salt mines or granaries. Berkelium is kept in the container made of lead or other materials that can block the radiations. Strict regulation. The Internal Atomic Agency (NRA) set the global standards for handling, transporting, and disposal of radioactive materials. This is a theoretical process where radioactive elements are converted into the less harmful ones, but it is not a practical for the most nuclear waste. Even with these measures, waste remains hazardous for thousands of years and must be constantly measured. Do you even think it is possible to make the radioactive waste completely safe? Why or why not? Should we keep producing it? Scientists value versus risk. There is ongoing debate about whether the knowledge gained from producing berkelium outweigh the risk and ethical concerns. Ethical questions: is it right to create the material that will remain dangerous for thousands of years just for scientific curiosity? Alternatives: researchers are looking for ways to minimize the waste or find a safer method for producing and studying having elements. Global cooperation. Managing radioactive waste and production is a global issue that requires international collaboration and regulations. Berkelium, a powerful yet fragile element. Scientific discovery. Berkelium has advanced our understanding of chemistry and nuclear science. Dangerous legacy. Its production and use leave behind hazardous waste and environmental risks. Future considerations. We must balance the fruit of scientific knowledge with our responsibility to protect people and the environment. In the purest of knowledge, we must also understand the responsibility we bear for the future. Use visual and also thank you. We must balance the perceived knowledge of our responsibilities. So, Berkelium has advanced our understanding of chemistry and sciences. Thank you for your attention. Thank you for your